Our lesson objective is I can evaluate trigonometric ratios in the first quadrant of the unit circle. So here we have three right triangles. We have three 45, 45, 90 triangles. And as you can see that the angles themselves are all the same, but what's different is the hypotenuse is different lengths, the sides are different lengths. So we want to really figure out what relationships do we notice between the sides. So anything you write here is fine, but I would just say something important to point out is that, so the legs in each triangle are congruent. The 4 radical 2, 3 radical 2, 3 radical 2, radical 2 over radical 2, they all stay consistent. And another thing that you can notice is that the hypotenuse is equal to radical 2 times one of the legs. So 6 is equal to 3 radical 2 times radical 2. Why? Square root of 2 times square root of 2 is 2. 3 times 2 is 6. So now we want to show how you can use any of the above triangles to find sine of 45 degrees and cosine of 45 degrees. So if we use sine of 45 degrees for, let's call this triangle A. We do sine of 45 degrees, that's 4 radical 2 over 8, which will just be radical 2 over 2. So this is for triangle A. What if we tried this for triangle B? We would have sine of 45 is equal to 3 radical 2 over 6, which again is just radical 2 over 2. What if we try now for triangle C? What do we think is going to happen? We do sine of 45, that's going to be radical 2 over 2 divided by 1, which is just radical 2 over 2. So as you can see, sine of 45 degrees is always the same. Now let's do cosine of 45 degrees. So again, if we do triangle A, I'm going to do it in the same color. Cosine of 45 degrees is going to be 4 radical 2 over 8, which is radical 2 over 2. Now let's try the second triangle. So we'll see here that cosine and sine of 45 degrees, no matter what triangle, will always be the same. So the significance that each of the cosine and sine values evaluate at 45 degrees with similar triangles is that their values never change no matter the size of the triangle. Similar figures have corresponding congruent angles and corresponding proportional sides. Okay, so we're going to consider another case known as a 30, 60, 90 triangle. And what I'm going to do is actually label these triangles A and B, and then I'm going to find sine of 30 degrees, cosine of 60 degrees, cosine of 30 degrees, and sine of 60 degrees using both of these triangles. So we're going to start with sine of 30 degrees. So for A here, we're going to say sine of 30 degrees is 4 over 8, which is 1/2. Then we're going to do triangle B, and that'll just be 1/2. So now we're going to do cosine of 60 degrees. So we'll start with triangle A. So we do cosine of 60 degrees. So over here, we have 60 degrees in the corner. So that's going to be 4 over 8, which is just 1/2. And then we'll use the second triangle. So we have 60 degrees here, and the adjacent side's 1/2. It'll just be over 1. So cosine of 60 degrees is just 1/2. So the first important thing that we need to recognize is that sine of 30 degrees is equal to 1/2, which is also the same thing as cosine of 60 degrees. So now we're going to do sine of 60 degrees and cosine of 30 degrees. Sine of 60 degrees, we're going to use the first triangle. So we have 60 degrees here, so that's going to be 4 radical 3 over 8. So that'll be 4 radical 3 over 8, which is just going to reduce to radical 3 over 2. Then we're going to have we're going to have sine of 60 degrees in the second triangle. So that's here. And the opposite side is radical 3 over 2 divided by 1. We'll leave it the same value. So this is radical 3 over 2. Now we can go ahead and do cosine of 30 degrees. Okay, so now we're going to do cosine of 30 degrees. We're going to use the triangle on the left, triangle A. So that's going to be the adjacent side over the hypotenuse. So that's going to be 4 radical 3 over 8, which is just going to be radical 3 over 2. Then we're going to do the second triangle. So we have cosine of 30 degrees, which is going to be radical 3 over 2 over 1, which will just be radical 3 over 2. So another important sine of 60 degrees equals radical 3 over 2, which is equal to cosine of 30 degrees. Here is a circle with a radius 1, and it's centered at the origin. We refer to this kind of circle as the unit circle. We know what the word circle means. The word unit, you may have heard it for unit of measurement. It means 1. So the way you can think about it, it's a circle and it has to do with 1, so it has to have a radius 1. So the idea of a unit circle is that the radius is 1, and any point on a graph, you could drop an altitude, and this would be your y value, and then this would be your x value. And because I dropped an altitude, this is a right triangle. So if I was interested in knowing to solve for x, we could set up an equation using trig functions. So we would do cosine of 30 degrees equals, because we have cosine of 30 degrees, x is our adjacent side, so it'll be x over 1. And anything divided by 1 will just be itself. So what we find here is that cosine of 30 degrees is x. And we know what cosine of 30 degrees is because we just spent an awful lot of time talking about it. It's 1/2. Now, if we were to do sine of 30 degrees, that, again, using our trig ratios, would be y, which is radical 3 over 2. So back to this problem. Cosine of 30 degrees is x, which is going to be radical 3 over 2. And then sine of 30 degrees is y, which is going to be 1/2. So I'm not going to spend an awful lot of time going over the rationale behind this because we just really discussed why these values correspond. So this value here, let me do it in a different color, corresponds to this value. This will be cosine of 45 degrees, because again, this is a right triangle. So this will be radical 2 over 2. And then this value here corresponds here, which will be sine of 45 degrees, which is also radical 2 over 2. And here we have a right triangle with a 60-degree angle. So cosine of 60 degrees is 1/2, and then sine of 60 degrees is radical 3 over 2. And then it says, determine tan of 60 degrees. Well, if we look at this triangle, we know this is radical 3 over 2, and then this is 1/2. So tan of 60 degrees is just going to be radical 3 over 2 divided by 1/2. And that will just be radical 3 over 2 times 2 over 1, which will be radical 3. So again, this is the idea of the unit circle. It is a circle that is constructed of various values using cosine and sine of theta, where we have a hypotenuse of 1. And it's at various angles that include our special right triangles. So we constructed the quadrant 1 today. So I'm going to draw that over here. So the way it's going to look is, I'm going to have a... All right, so we have, this is quadrant 1. So we have our unit circle here. So this is the point 1, 0, and this is the point 0, 1. This is our y-axis, and this is our x-axis. So we have a 30-degree angle here. That is going to correspond with radical 3/2, 1/2. Then we have a 45-degree angle here. That's going to correspond with radical 2/2, radical 2/2. And then we have a 60-degree angle here, and that's going to be 1/2, radical 3/2. So you might wonder, how am I going to remember all these values? Well, a good idea is, I know that's hard to remember, so the way I like to think about it is that going from the x-axis to the y-axis, think 3, 2, 1. And just remember, the radical 3 values always go with the 1/2 values, and the radical 2 always just go with themselves.